Okay, what we're going to be doing today is kind of review. Review from grade 11. Because in grade 11 we had to do maximum and minimums, or what we call optimization problems, right? What's the best profit we can make? And you remember we used to graph them and we'd find the max? Remember how we did that using max in our calculator? What's the other way to find the vertex besides the calculator? Completing the square. So this is actually easier than completing the square. Much quicker. You can derive to find a maximum, can't you? Because maximums occur at slope is 0. And minimums occur at slope equals 0. So it's actually way faster. So if we could go back to those grade 11 problems, you'd find out that they could have been done way faster if you had a derivative base knowledge. Okay, so maximum min problems. Remember what we were doing last in grade 11, we were trying to find out the most profit or whatever, but maximum and minimums, right? So if I just drew this kind of example here, so here's a max and here's a min. Now they're relative maxes and relative mins, but at max and mins we know that slope equals 0. Okay, so these are optimization problems. Now optimization doesn't always mean maximum. Okay, sometimes you want to be the most efficient or you want to have the least amount of cost. Okay, not the maximum profit, maybe you want least cost, right? So maximum profit, minimum cost for building a pipeline, maximum volume of water, minimum distance between, what's the minimum those two people will ever be apart if one was going this way, one was going this way, okay? Now, let's go through this quick. Method for solving these. First of all, identify the max min variable. So identify the max min variable. Okay, let's call this Q. Number 2, identify all other variables. Okay, place them on a diagram. Good old diagram again. 3, find the equation describing the max min. The max min variable Q. Okay, now number 4 is kind of an important one. If Q is described in terms of more than one variable, okay, so let's say X and Y, then we need to find an equation between the variables. X and Y. Similar to when we were using the triangles, the similar triangles for the quiz today. And then you want to isolate one variable and sub this into original equation. If you're successful, q will be in the function of only one variable. So what we're looking for is q and x, and we want to go find maybe the maximum. So this is where 5 comes into place. Use the first derivative. Test to find max min. Okay, you may have to use implicit differentiation. And then you find, sorry, this should be the second one. Find the critical values. That's where q prime equals 0. Because when slope equals 0, that is when it's a max. And then you find max or min. And then good old 6 is state your answer in words. Okay, so let's start off with the easiest possible question we could possibly do, right out of grade 11. Find two numbers whose sum is 34 and their product is a maximum, okay? So this is where we want to be thinking of using our derivative on. Not the two numbers whose sum is 34, but whose product is a maximum. So we've got two numbers, right? So product equals x times y. That's the one we want to maximize, right? So how can we relate those two? Because we want to get rid of one variable. Again, doesn't matter which variable you want to get rid of, but we know, so this is equation 1, and hey, if it only had one variable in it, we could just take the derivative and we're done. Unfortunately, it has two, so we have to relate them another way, and that's why they gave us this. So x plus y equals 34. Okay, so we minus x, y equals 34 minus x. So now we can sub this into here. So 3p would equal x times 34 minus x. And if we don't want to use the product law, we can factor it out. P equals 34x minus x squared. Or you could just go use the product law, right? So now let's find p prime. Okay, now since this is all going to be to x, because there's x's here, we will go dp over dx equals 34 minus 2x. And we don't have to go dx over dx because those would cancel. Now, 5 is find max. And max is going to occur when dp over dx equals dp over dx equals 0. So 0 equals 34 minus 2x. 2x equals 34. x equals 17. Okay, so, and then y equals 34 minus 17, which equals 17. The two numbers are 17 and 17. If you had a graphing calculator, graph it, find the max, left, right, enter. It would give you 17 as your x, and it would actually give you 17 as the y too. Or you can complete the square on it, and you would get 17 as the x for the PQ. Okay, so you probably remember these quite fondly when you're building a fence. Yes, could be, yeah. So a farmer wants to close a large possible rectangular pen for his chickens using 300 meters of fencing. Find the dimensions of the rectangle if he plans to use the barn or as one of the sides. So largest possible rectangle. So what are we looking for? Max area, right? We want max area. So always try and figure that out first so you have that formula. Now area equals L times W, right? Okay, so if we draw ourselves, usually that's how you put a wall or whatever, a barn. Okay, and then we're going to put fencing around it. Okay, this will be the width. This will be the length. Now we don't know the length or the width. Right? So, but we've got to get rid of one variable. Doesn't matter what variable you're going to get rid of. But we know that perimeter equals, in this case, 2w plus L. Okay, not 2L plus 2w. Would be for a normal rectangle, but this one side is not being fenced. 300 equals 2w plus L. Got that right from the sentence. Okay, and I just subtracted the 2w from here, from each side to get this. This is going in here. Area equals 300 minus 2w times w. Again, you could use the product law, or you could just multiply it all in. This is 300w minus 2w squared. Okay, so now we're all good. Let's do the derivative. So dA with respect to w equals 300 minus 4w. Okay, so we're going to now find the max. This would occur when dA over dw equals 0. Equals 300 minus 4w. 4w equals 300. W equals 75. Okay, so I know the width. The length equals 300. I'm going to use this. Minus 2 times 75. This equals 150. So the max area. So I didn't ask for the max area. You could put that if you wanted to. But the max area occurs when L equals 150 meters and equals 75 meters. Okay, those are kind of nice ones, right? Unfortunately, it's not going to stay that nice. A train leaves Edmonton at 7 and drives directly east at 10. Oh yeah, let's switch these because that is a very slow train. So let's make this 100 kilometers per hour. At the same time, a bus leaves, a bus that is, let's make this 300 kilometers directly south of Edmonton, travels towards Edmonton at a rate of 90 kilometers per hour. At what time will they be closest together? So we're looking for a minimum time. Okay, so we want minimum time. Okay, so over here on the left side, let's kind of, we got, let's call this Edmonton right here. We got a train leaving Edmonton, and it's going directly east. Right. Okay. And here, I'll put this. Okay, so we got Edmonton, and we're on a train that is going 100 kilometers per hour. Now, at the same time, a bus that is 300 kilometers directly south. Okay, so here we are over here. This is where our bus is. And it is going at 90 kilometers an hour. So this is train. This is bus. It's going at 90 kilometers per hour. And we want to know, okay, maybe I shouldn't draw this so long, because we want to know, when is this a minimum? So if we know when that's a minimum, it should give us the time when that happens. Okay, so let's call this X. And we'll call the, oops, I should have done that in red. And we'll call our bus Y. Now we know the velocities. We know the distance that the bus has to go. Okay. So this one is a bit on the trickier side, but once you see it once, okay. Well, we know that distance equals velocity times time. So the train, D will equal 100t, and the bus, D will equal 90t. So if I was to draw this triangle again right here, and again this is the distance that the train would go would be 100t. Now the bus is going to be kind of different, because from here to here is 90t. Now remember, 90t means distance, right? So this is 100t. This is 90. What is this? What's this distance here? Okay, very good. Okay, so this would be, this distance here will be 300 minus 90t. That would be that distance. And now we have a Pythagoras relationship. 300 minus 90t. Why is it 300? Because it's 300 directly south. And every second that 300 will get smaller and smaller and smaller. Okay, so let's call this d then, because if we minimize d, that is the closest they're together. That is the, and then we can figure out the time that that distance is happening. Okay, so remember this was x, and this will be y. So we know that d squared equals x squared plus y squared. Okay, so let's, so d squared equals 100 t squared plus 300 minus 90t squared. So this is distance squared equals x squared plus y squared. Okay? So now at this point, I can just go, now, you don't want to really have to square this, 300 minus 90t, so let's go right to find the derivative. That would be 2d, and then dd over dt equals 2 times 100 t times 100. I'm using the chain rule, and I don't have to go dt over dt, plus 2 times 300 minus 90t times negative 90. Yeah, 2d times dd over dt. Now, because everybody's got a 2, we divide everybody by 2. And we can simplify a bit if you want. dd over dt equals 10,000 t minus plus or minus 2,700 plus 8,100 t. 27,000, sorry. Okay. Now, do the max. Or no, this one's a min. No, yeah, min. So 0 equals, see, d times 0 is 0, so it does cancel that on that one side. Well, I guess I could get, let's get the t's together. That would be 8,100 is coming over there to be 100 or 18,100 t minus 2,700. 27,000. I don't know why I keep saying that. So you can bring the 27,000 over to this side. 18,100 t. And then divide it out. 27,000 over 180. 18,100 t. And you will get 1.49 hours. Now, they wanted to know to the nearest minute. So it's not 1 hour and 49 minutes. That's 1.5 hours, basically. So 1.49, you want to take this and multiply by 60. And it works out to be 1 hour, 29 minutes. So they are the closest at 1 hour and 29 minutes. Oh yeah, yeah. So at 8:29 a.m. Well, it's not the same thing. It's just usually the graph won't have a max and a min on it. So unless the question is so messed up, right? That's not fair though, right? So when it asks you for min, set it to 0. Yep. Well, you just set it to 0. If you look at the formula, because it's a positive x squared graph and they only go like this, right? But I'm not going to be mean like that and say find out what it is, right? Max or min. I just set it to 0. And then of course ones that ever have a negative in front of the x squared will go like that, right? So then you know it's a max, right? And they were always set up for you that well in grade 11 too, right? And no one questioned it. They just thought, okay, it's always working out. I'm happy. I'm good. Now this one here, you can totally do without calculus, but well, all of these you could figure it out without calculus. Actually, it takes a lot longer. And this one you've done many times before, but we'll do it using calculus. Okay, so find the closest point on the function of y equals 3x squared, or 3x plus 2, from the point to negative 2. Okay, so let's just do a drawing quick here. Let's graph this 3x plus 2. Now remember, this is the y int, right? So we're at like 2, and this is the slope. So we're going to go up 3, 1, 2, 3, come over 1, be about there. So let's say this is our line here. So that is y equals 3x plus 2. And we want to know what's the closest point from this line to negative 2, oh, right there. Okay. And you would know that that's a 90. So in the past, I would know the slope of this is what? Does anyone know what the slope of this would be? Negative 1 over 3. You know a point, so you can find the equation of this line. Take the equation of this line, make it equal that, and you'll find the x value right here. Then go find the y value using one of them. That's the way we've done it before. But this is a max min because this is actually the minimum distance. From here, any other way to go to this line would be a greater distance. Okay? There's a billion ways to go here if you want to go longer, but the shortest is always going to be a 90 to that line. Okay? So here's like a river and this is where you are. The shortest distance would be straight to the river, obviously. Now, so we want to find minimum distance. So the way you find minimum distance from here, So from A to B would be to use your distance formula. Okay? And distance formula is this: x2 minus x1 squared plus y2 minus y1 squared. Now, I'm going to be finding the derivative of this, right? So, life will be easier if you change it to this. Okay, or else you're going to have to use the chain rule. Okay, now we do know 1 point. That's going to stay consistent, so if we want, we can put that in there. D squared equals x minus 2 squared plus y minus negative 2 is plus 2 squared. Now, and that's why this one is just another unique kind of problem, but we actually know this point right here, right, is x comma y, right? But what is y? It's 3x plus 2. So this is actually x comma 3x plus 2. And do you see how now I automatically got rid of a variable? Okay? So d squared equals x minus 2 squared plus 3x plus 2 plus 2 squared. B squared equals x minus 2 squared plus 3x plus 4 squared. Okay, so now we got everything to one variable. Let's do the derivative. So we've got 2d d over dx equals 2x minus 2 squared times 1. I'm going to put the times 1 so people get, I know someone yesterday, they were doing a derivative and they had to use the chain rule and they said, we still have to use the chain rule? Yeah, you still have to. Oh yeah, exactly. Okay. And then 2 times 3x plus 4 times 3. Okay. Again, 2's can go by. And then we've got d over dx equals x minus 2 plus 9x plus 12. d over dx equals x plus 9x is 10x. And then negative 2 plus 12 is 10. So we want to find the min. So that's going to be, so dd over dx equals 0. So this will be 0 equals 10x plus 10. Negative 10 equals 10x. Negative 1 equals x. So we want to plug that into 3x plus 2, right? So y equals 3 times negative 1 plus 2. Y equals negative 1. And if you did a good diagram, it should kind of match up. So the nearest point is negative 1, negative 1. right? I'm doing the derivative of d all the way down with respect to x. What's on the other side here? Okay, if there was t's here, the last one was t's, all here. Okay, and if you look back at the other two, right, there was x's here, so that's why I did it. And here I did dA, dW, because there's w's here. Okay? Oh, everyone's got the homework? It's on your sheet. Okay, so it's page 189, 1, 2, 3, 5, 8, 10 to 12.